Good morning, children. This is ninth physics, chapter 8 motion, topic number 9, that is graphical representation of motion. Now, let's see what we are going to learn. Children, we will learn drawing distance time graph. This is your distance time graph for uniform motion, for non-uniform motion, and when the object is at rest, right? Then we will learn to calculate the speed. We will learn to calculate the value of speed from distance time graph, right children? And after that we will see velocity time graph for uniform accelerated motion, uniform retarded motion, and for zero acceleration or constant velocity. As we know, if the velocity is constant, that is initial velocity and final velocity, they are same, they are constant, they are fixed, then the change in velocity, that is your acceleration, will be zero. So for that, and from velocity time graph, how to calculate acceleration and displacement, that we are going to learn in this lecture. So let's start with it. So children, this is your distance time graph. This is your distance time graph. Now, here we can see there are three graphs. Let's start with the first one. Here in the first graph, on y-axis we have taken distance and on x-axis we are taking time. Distance we have taken in meter and time we have taken in second. Now we are plotting the graph, and when we plot the graph, we are seeing that at time t equals to 1 second, the distance of the object is 2 meter, right? When the time is 2 seconds, the distance of the object is 4 meter from your origin. Yes? Then children, further, at time t equals to 3 seconds, the distance covered by the object is 6 meter from the origin. So similarly, if we plot the graph, then over here we are getting a straight line graph which is passing through the origin. So this straight line graph, it shows you that equal distance is covered in equal interval of time. Is that so? Let us check. In time 1 second, distance covered is 2 meter. Again in the gap of 1 second, that is 2 minus 1, this gap, the distance covered is 4 minus 2, that is 2 meter. Yes. Let's see how much distance is covered in the next 1 second. Now in this 1 second, the distance covered is 4, that is 6 minus 4, and it is 2 meter. So here children we can see that in each second, 2 meter of distance is covered. So equal distance, that is 2 meter, is covered in equal interval of time, that is 1 second. So this graph shows you uniform motion. So for uniform motion, the distance time graph is a straight line graph, right? This is for uniform motion. Now children, if the motion is not uniform, that is in 1 second, suppose it is covering a distance of 1 meter, then in 2 seconds it is covering a distance of 3 meter, then in 3 seconds it is covering a distance of suppose 6 meter, in 4 seconds it is covering a distance of, I don't know, it's how much, 12, 14, whatever you say, let's go, right? So here you can see children that equal distance is not covered in equal interval of time. Yes, unequal distance is covered. So this is your graph for non-uniform motion. So the graph of non-uniform motion for distance versus time is a curve. It is not a straight line graph, right children? So uniform motion, the distance time graph is a straight line graph, right? It is straight line graph that is passing through origin. For non-uniform motion, the distance time graph is a curve. It is a curve. Uniform motion, non-uniform motion. Now let's see. Here children, at time t equals to 1 or initially at time t equals to 0, the object is at 8 meter away from the origin. At time t equals to 1, the object is still at 8 meter. Okay. At time t equals to 2 seconds, the object is still at 8 meters. And at time t equals to 3 seconds, the object is still 8 meters away from the origin. So children, as you can see that the distance throughout is 8 meter only. So distance is not changing, right, with time. So what does it prove? It shows that your object is at rest. Your object is not moving. It is at rest. So when the object is at rest, we get a straight line which is parallel to the x-axis. So you can see here our graph line, that is this blue line, is parallel to the x-axis, or you can say x-axis पे हमने क्या लिया है? Time. So you can either use the word x-axis or you can use the word time axis. So these are the children 3 distance time graph. First one, for uniform motion, it is a straight line graph, right? For non-uniform motion, it is a curve. And third, when the object is at rest, the distance time graph is a straight line parallel to x-axis or time axis. Right, children? Now, so we are clear with these 3 graphs? Okay. So let's proceed. How can we calculate speed from distance time graph? Now, children, this graph, now we are going to focus on this graph, that is the graph for uniform motion. Your uniform motion graph is going to give you the value of speed, will give you the value of speed. Now children, I will introduce to you a word, that is slope. Okay children. Now, if we want to find out speed of the object, then children, that can be done by calculating the slope of your distance time graph. Slope means the graph line is at what angle, right? How much inclined it is with the x-axis. So as we know, this is our graph line. This is our graph line. Then with the x-axis, what angle, how much it is inclined, right? That gives you the value of slope. So children, slope is defined as change in y coordinate upon change in x coordinate, right? Change in y coordinate upon change in x coordinate, right children? This is your slope. Now, I'll help you how to find out the slope. So we will follow few steps to find the slope. First of all, what you will do is, on your graph line, that is on your this graph line, we will select 2 points, right? You can select any 2 points on this graph line. Suppose I am selecting point A, this is first point, and point C. So this is my point number 1 and this is my point number 2. These are the 2 points which I have selected, right? Now from point number 1, I will draw a dotted line on the x-axis. So this gives me the value of x1. Because I have drawn from point 1 and it is on x-axis, so it gives me the value of x1. So x1 value is 2 seconds. Now from the same point 1, I will draw a dotted line on y-axis. And here on y-axis, it will give me the value of y1. It will give me the value of y1. Similarly, children, for point 2, from point 2, I am drawing a dotted line on x-axis. So it gives me the value of x2, that is 5 seconds. And from the same point 2, I am drawing a dotted line on y-axis. which gives me the value of y2. Right, children? So from point 1, I have drawn a dotted line on x-axis and it gives me the value of x1, that is 2 seconds. And from the same point 1, I am drawing a dotted line on y-axis and it gives me the value of y1, that is 4 meter. Now from point 2, we have drawn a dotted line on x-axis and it gives us the value of x2, that is 5 seconds. And from the same point 2, if we draw a dotted line on y-axis, it gives us the value of y2, that is 10 meter. Right. Now children, when we are moving from point 1 towards point 2, when we move from point 1 to point 2, towards point 2, there is change in the coordinates. There is change in their y coordinate as well as there is change in their x coordinate. Their y values are changing, their x values are also changing. Suppose you see at point 1, value of y is 4, right? At point 2, the value of y is 10. So it has changed from 4 to 10. Right, children? Similarly, when you are moving from point 1 towards point 2, the value of x coordinate has also changed. At 1, the x coordinate is 2. And at 2, the x coordinate is 5. So the x coordinate has changed when you moved from point 1 to point 2. Towards point 2. So there is change in y coordinate and there is change in x coordinate also. So change in y coordinate will be given by y2 minus y1. Change in y coordinate will be given by y2 minus y1 and change in x coordinate will be given by x2 minus x1. Right, children? So just a second, children. Oh God. So children, here the change in y coordinate is y2 minus y1 and change in x coordinate is x2 minus x1. So here it is, right? And if we put the values, we'll get 10 minus 4 because the values are changing from 4 to 10 in y coordinate. So it is 10 minus 4 and on x axis it is changing from 2 to 5. So it is 5 minus 2. So 10 minus 4 is 6, 5 minus 2 is 3, 6 by 3. So the slope is 2. The slope is 2. And if we just focus on the unit, it is what? 2 meter per second. And we know that meter per second is the unit of speed. You might say that, ma'am, meter per second is also the unit of velocity. But beta, if in velocity we had displacement, but here we are having the graph of distance versus time, distance. So as your distance is involved, as your children distance is involved, the parameter that we will get by calculating the slope is speed. So your speed is 2 meter per second. Right, children? So let me summarize how to find out the slope of a graph. So children, for finding out the slope, the first and foremost step you are going to do is you need to calculate, you need to select any 2 points on the graph line. Whichever is your graph line, first step you will select 2 points and you will name them A, B, right? Or you can name them as 1, 2 also, no problem in that. Then from the first point, you will draw a dotted line on x-axis and you will name the coordinate over there as x1. And from the same point, you will draw a dotted line on y-axis and you will name the coordinate as y1. This is about point 1. Now we will proceed towards point 2. So when we move towards point 2, children, when we are moving towards point 2, From point 2 also the same procedure we are going to do. That is, from point 2 we are going to draw a dotted line on x-axis and we will name it as x2 and we'll see its value. And from the same point we will draw a perpendicular dotted line on y-axis and it will give you the value of y2. And then we will put the values of y2, y1, x2, x1 in the formula of slope, which will help you to calculate the value of speed. So children, distance time graph helps you with the value of speed of the object. It gives you the value of speed of the object. So from distance time graph, we can calculate the speed of the object by finding the slope of the graph line. Okay, children? So this is your distance time graph. Now, let's proceed to the next graph, and that is your velocity time graph. That is your velocity time graph. Okay, children. Now let's start with velocity time graph. So children, in velocity time graph, we are going to see 4 cases. First case is of uniform acceleration. Uniform acceleration is equal change in velocity in equal interval of time. Right, children? Uniform retardation. Uniform retardation is the change in the velocity is in decreasing form. So the decrease in velocity is equal in equal interval of time. And uniform acceleration, the increase in velocity is equal in equal interval of time. Non-uniform acceleration means it is just a random motion. Sometime during some phase, the velocity may be increasing, then decreasing, then it may increase, decrease, means it is just a random motion. So that will come under non-uniform acceleration. There is no equal change in velocity, right? And last case which we are going to see is your zero acceleration. Means your velocity is constant. You are moving on your Activa towards your school at a constant speed, 30 km per hour. Aram se you are moving. So that is constant speed, constant velocity, right? And that is your zero acceleration. Now let's see. For the first graph, that is uniform acceleration. Now if you see this graph, at time t equals to 1 second, the velocity is 10. Then at time t equals to 2 seconds, the velocity is 20 meter per second. Then at time t equals to 3 seconds, the velocity is 30. So beta, if we look at the change in velocity, initially your Activa is at 0, 0, you have not started. But after 1 second, you are moving with the velocity you saw in your speedometer, it is showing 10. Then after 2 seconds, it is showing 20. And after 3 seconds, your speedometer is showing 30. So the change in velocity, यहाँ पे कितना change हुआ? 10 meter per second. Here how much is the change? 20 minus 10. Again 10 meter per second. Here in this second, how much is the change? 30 minus 20. Again it is 10 meter per second. So beta, your velocity is constantly increasing by 10 meter per second. So as your velocity is increasing, as your change in velocity is equal, that is 10 meter per second in every second. So this is the graph of uniform acceleration. So velocity time graph, you have to be very careful which graph is asked to you, right? So velocity time graph for uniform acceleration, uniform accelerated motion is a straight line graph. This is for acceleration. Now, if we are talking about negative acceleration or retardation, so it is decrease. The velocity is going to decrease. So let's see. Here at time t equals to 0 means at the time we started noting it, right? So at 0, the velocity is 50 meter per second. After 1 second, we are saying that its velocity is 40. After next second, we are checking its velocity is 30. At third second, the velocity is 20. At fourth second, the velocity is 10. Right, children? So here you can see that slowly and steadily there is decrease in the velocity. And this decrease in velocity is equal in equal interval of time. Every second the velocity is getting decreased by 10 meter per second. So as the decrease in velocity is equal in equal interval of time, this shows you the graph of uniform retarded motion. Right, children? Next, non-uniform acceleration. This can be any zigzag path you can draw. That at this time it might be increasing, decreasing, up, down, right? So it is a zigzag path. Last, here we will see that at time t equals to 0, your activa is moving at 30 meter per second, or an insect is moving at 30 meter per second. Then you saw at time t equals to 1 second, again the insect was moving with the same velocity. Insect was moving on a straight path and its velocity was 30 only. And after one more second, that is time t equals to 2 seconds, the velocity remained the same. So the velocity is remaining constant throughout. So this shows you the graph for constant velocity, or the graph for zero acceleration. That is, it is a straight line parallel to the time axis. Right, children? This is your velocity time graph. In distance time graph also we had such a graph, na? But that was for object at rest. So be very careful. When it is distance time graph and you are getting such parallel line to x-axis, the object is at rest, because distance is not changing. Distance वही है, means आपकी scooty वहीं खड़ी है. So it is at rest for distance time graph. But here your scooty is moving constantly with 30 meter per second. So it is not at rest, it is moving, but speed is constant. Okay, then this is your velocity time graph for zero acceleration or constant velocity. Right, children? Now, this velocity time graph, है ना बेटा, this graph is going to give you, velocity time graph is going to give you, children, two values. Distance time graph gave us only one value. Which value? Speed, by calculating slope. But velocity time graph is going to give you two values, right? First value it's going to give you is the same, that is by finding the slope. Now we know how to find the slope, right? So by finding the slope of velocity time graph, we will get the value of acceleration. Let's see how. Yes, children, slope we know is change in y coordinate upon change in x coordinate. That is y2 minus y1 upon x2 minus x1. Now here, children, the y coordinates are what? On y-axis, we are having velocity. Yes, on y-axis, we are having velocity. This is a velocity time graph. So on y-axis, what we are having? This is velocity. So change in y, slope equals to change in y upon change in x. Y पे क्या है? Velocity. Upon change in x. X पे क्या है? Time. So we know velocity, change in velocity upon change in time is acceleration. That is what is the definition of acceleration, na? That is change in velocity, right? Change in velocity, है ना बेटा? Upon time. So slope of velocity time graph is going to give you the value of acceleration. Right, children? So same you are going to do here. Select 2 points. This is selected, number 1, number 2. From first point, dotted line on x-axis, x1. From first point, perpendicular dotted line on y-axis, it gives you the value of y1. From second point, draw a dotted line on x-axis, it gives you value of x2. From the same second point, draw a perpendicular dotted line on y-axis, it will give you the value of y2. Now, slope equals to y2 minus y1 upon x2 minus x1. So slope equals to y2 minus y1. y2 is 40, y1 is 20. Unit क्या है इसका? मीटर पर सेकेंड. Upon x2 क्या है? 4 seconds minus 2 seconds. This is 20 by 2 meter per second square. So the acceleration is 10 meter per second square. See the unit, meter per second square. We know it's the unit of acceleration. है ना? So children, velocity time graph slope gives you the value of acceleration. Now, I told you it will give you two values, right? Second value, what it will give you is the slope gives you the value of acceleration. The area under the graph, suppose your graph line is this, right children? Now, the area under this graph, this area will give you the value of distance. It will give you the value of distance. So if we see this carefully children, this is a triangle, right children? It is a triangle OP and I think R, okay, OPR. We know the formula. So distance symbol is S equals to area under the graph. Graph के नीचे जो बना है figure, that is a triangle. So area of triangle OPR, that is half base into height. हमें पता है triangle area formula, that is half base into height. Right children? Now what is the value of base over here? Base, if we see carefully, base is this. That is 5 seconds. So base is 5 seconds. Height is how much? Height is 50 meter per second. 50 meter per second. And this is 5 seconds. Right children? So children, this is half into 5 seconds into 50 seconds. So this will give you the answer. If you divide it, your final answer will be how much it is? 125. Yes, it's 125 meter. So 125 meter, because your second will get cancelled and you are getting the answer in meter. So children, here I have explained it that the distance can be calculated by calculating the area under the graph. So area under the graph, it was a triangle. So half base into height. And if you substitute the distance that is traveled by the object. So children, be very careful that your velocity time graph gives you two values. First is by calculating the slope, we will get the value of acceleration. And second thing, by calculating the area under the graph, we get the value of distance, that is S. Okay children, I hope this is clear. In the next class, we will solve some numericals based on this. Fine children? Okay children, bye bye. Take care.